Hello, pre-calculus students. This is Mr. McAllen, and today we're going to be doing another day of the flipped classroom. This is our fourth day in our sixth unit. In this video, we're going to go over a special type of problem that you'll find on college entrance exams when you don't have a calculator. Also, these are classic questions that we like to ask as pre-calculus teachers to see if you can find the 6 trig ratios if you're given a point that lies on the angle's terminal side. So we're going to practice this problem. I'm going to instruct you how to do it. I'm going to give you a problem for notes, and then I'm going to have you do one on your own. So in this discussion, I'm going to also talk about vectors. Now, if you've had physics and you know what vectors are, then this should be kind of a review. And I'm going to discuss using the reference angle to help us find the trig ratios. So we haven't discussed reference angle yet. Today we'll be introducing the idea of what the reference angle is. So moving along, our first example, just watch this example. You don't need to take any notes, just see how it's done. It says the terminal side of an angle in standard position passes through the point 3, -2. So it's important that you know how to plot points, and I'm assuming if you made it to pre-calculus, plotting points is not an issue. Find the 6 trig ratios of this angle. So we're going to plot an angle. We're going to first plot the point and then plot the angle through that point. So we go to 3, -2. So we go out to 3, down 2, and our point would be right there. So our angle is going to be that's a black line. Let me just I'll just make that blue so you can see that. And we go around to that angle that would have its terminal side passing through that point. So I don't know what angle this is. I have no idea what the quantity of that angle measurement would be, but that's my angle. And this angle right here is theta. That's my reference angle. So I'm going to label the coordinates 3, -2. I'm going to draw on the angle. I'm going to draw the sides that make up the angle. I'll use some really thick marker so you can see that. So this is one side. This is the other side of the right triangle that would make up this angle. These sides are, this is -2 because it goes down from the origin, and this is a side of +3. It's very important that you recognize what the side lengths are and what their sign is. A vector in physics is it represents a magnitude and a direction. So just saying 3 and 2 is not enough. You need to think about what direction that angle is going in, or that side is directed towards. Is it up or down? If it's up, it's positive. If it's down, it's negative. If it's to the right, it's positive. If it's to the left, it's negative. So now I have almost everything I need for my 6 trig ratios. I just need to find the hypotenuse. So this is a Pythagorean theorem problem. So I'll just call this h for the hypotenuse, or some people will call this the radius of the terminal side. So I'm just going to write 3 squared plus, this is -2 squared, equals, I'm going to use h for hypotenuse squared because most of us are, right now we want to call that the hypotenuse. So hypotenuse squared is just equal to, make sure when you square a negative, you remember it's positive. So we have 9 plus 4. The hypotenuse is equal to the square root. Hypotenuse squared is equal to 13, and our hypotenuse would be root 13. Please don't convert this to a decimal. We're trying to give exact answers. So the sign ratio is going to be the opposite side over the hypotenuse. The opposite side is -2, so our ratio is going to be -2 over root 13. The cosine ratio is going to be +3 over root 13, because that is the adjacent side to the reference angle. The tangent ratio is going to be the opposite side, -2 over the adjacent, which is 3. Now we work on the cosecant of theta. That will be just the reciprocal of the sine ratio, root 13 over 2. Remember that was negative. Then we have the secant ratio, which is root 13 over 3. That's positive still. And the cotangent ratio, which is going to be negative 3 over 2. Only thing left to be done is to rationalize fractions that need to be rationalized. So the sine ratio needs to be rationalized, and that would equal negative 2 root 13 over 13, and the cosine ratio would be 3 root 13 over 13. A word of advice when you're putting this together, if you have a fraction that needs to be rationalized, wait until the very end of doing the 6 ratios. So that way you can just do the reciprocal first, and then if rationalizing needs to be done, you just identify the ratios that have a radical in the bottom. Now, let's look at one for your notes. You should jot this down, this problem, and then we'll work through it. So I'm going to pause the video while you jot down the information. So as I pause it, you should take a moment to write it in your notebooks. Okay, well, we're back. Hopefully you wrote it down. And now we're gonna plot the terminal side of the angle passing through this point. So we're first gonna plot that point. We go negative 1, 2, 3, 4, 5. We're up 4. So we're gonna label that point as negative 5, 4. Draw our terminal side through it. So here's the initial side, and here is the terminal side. I'm just going to draw that initial side again. And this is the angle theta, but this is the reference angle. The reference angle is always the angle that has the x-axis and the acute angle with the terminal side. So our sides would be, this side would equal 4, this side would equal negative 5, and then we have to use our Pythagorean theorem to find the missing side. Pythagorean theorem would say this is a square root of 41. Remember, it's going to be 4 squared plus negative 5 squared equals the hypotenuse squared. Hypotenuse will be 41 when you add up and take the square root. And then now we're ready to do all of our trig ratios. So the sine ratio, the cosine ratio, tangent, cosecant of theta, secant of theta, and cotangent of theta. So I'm just going to go right through it quickly. Remember, I've got to keep in mind positive and negative values. So the sine ratio is opposite over hypotenuse, 4 over root 41. I'm just going to write root 41 over 4 for this one. It's reciprocal. The cosine is negative 5 over root 41. This will be root 41 over 5, and that's still negative. Tangent is going to be opposite over adjacent, so that's going to be 4 is opposite, and 5 is the adjacent, and then this is just negative 5 over 4. We're done with all of our ratios. The only thing left now to do is to rationalize denominators with radicals in them. So this would become 4 root 41 over 41. This one for cosine would become negative 5 root 41 over 41. These are all exact answers with rationalized fractions. So please take note of that and consider doing it in this process, because it does lead to the least amount of problems, especially when you have to do the reciprocal sine or cosine or tangent ratio counterparts. Last problem is for you to try. I'm going to pause the video. I want you to do this one completely on your own. When I come back from the video, you'll see the solution. Okay, well, we're back, and what I've done is I've drawn out exactly what we did before. And just so that you know, I drew the initial side and the terminal side in green. The reference angle is this little angle here that's acute. That's between the x-axis and the terminal side. And I labeled the sides to be negative 4, negative 3 for the x and the y parts of that terminal side. So looking over at your answers, you can see that fortunately for this one, we'd end up with a radical number for the hypotenuse, and as a result, we had nice, easy fractions to look at. I just want you to take note that the tangent ratio was equal to -3 divided by -4, which the negatives cancel. So that's why both the tangent and the cotangent are positive. The other thing I want to point out is a quick tip on this idea of the reference angle. Our reference angle, no matter where the terminal side will land, is going to be what's called part of a bow tie triangle. So the reference angle will always be one of these four little reference angles. So it all depends on what quadrant your terminal side lands in. But if you draw a reference triangle that is not forming part of that bow tie, you've picked the wrong place to put your reference angle. So that's something that we'll talk about more tomorrow, but just to kind of clue you in as far as why I was picking the reference angle to go between the x-axis and the terminal side, that's the reason why. It's always the angle that's between 0 and 90 degrees, starting from the nearest x-axis to the terminal side. Hope this helps out, and I look forward to hearing your comments when we meet again.